Hi everyone, in this example I'm going to work through another problem where we have to find a quadratic equation for ourselves based on a certain situation and then calculate a maximum to answer our question. So here, this one's sort of confusing sounding. I would give you a picture probably if I didn't think I was doing it with you. I'll show you what I'm picturing. So we have a river with a 45-degree bend, meaning this is 45 degrees. And we're trying to trap an area around that bend, something like this. So again, I know the wording of this might not have completely led you to that picture. I will either, when you're on your own, give you more wording or give you a picture, but this is what I'm visualizing for this one. Okay, so we want to, let's see, we have one more piece of information. We want to trap this area with 1 mile of fence. So this and this have to add up to 1 mile. We don't have to fence along the river, so only trapping these two sides with the 1 mile of fence. We are supposed to find the dimensions of the largest possible pen. So this is looking like another maximize area to me. So I'm going to go ahead and use my A for area. And then we have the same thing as before where it's maybe not immediately obvious what your other variable should be. What is it that we're deciding or controlling? It's definitely something about dimensions, but I would maybe go another step or two with how we would find the area of the pen and hope that that gives me some good ideas. Okay, so this is a trapezoid, and if you have formulas for areas of trapezoid memorized, you can use them. What I would do is just split this up into a triangle and a rectangle and say this is the area of the little triangle plus the area of the rectangle. And again, we're balancing some things here. So if we make this side longer, that's going to force our pen to get a little shorter. And if we make the base shorter, it's going to get the other side to be longer. So we are balancing out, making one side longer with making the other side longer and trying to figure out where we get, usually somewhere in the middle, where we get the biggest possible area. Okay, so area of a triangle, that's a 1/2 base times height. And the area of a rectangle is a length times width. So now when I'm looking back at the picture, now that I've chopped it up a little, I'm interested in the base and the height of the triangle. I'm also interested in the length and the width of the rectangle. And I'm looking for a variable that will be able to represent all of those. So again, I'm not saying every single one of those should be X, but I should be able to relate all of those back to X. So one that jumps out at me is that these two are the same. So I'm going to go ahead and make that my X as a starting place. And then there is a little bit of trig involved. I promise on your homework and on your test you won't have a little bit of trig involved, but since I'm doing this one for you, I figured it was okay to just have a very little bit in here. So we do have to know a little bit about triangles to figure out this side. So what we've got here, this is a 90-degree angle, which means if there's 45 degrees up here, there should be 45 degrees down here. This is also a right angle, which means we're looking at a 45, 45, 90 triangle. And because these two angles are the same, 45, 45, 90, we have some really nice symmetry. If this side is X, then this side is also X. So again, I promise not to give you angle stuff on your homework or your test, but for this one, I really like to have a little bit different picture with that triangle. Okay, so we only have one thing remaining, so let's go ahead and fill in 1/2 X times X. So we've got the base and the height of the triangle. Width. There we go. Let's go ahead and say this is the length of the rectangle. So we don't have that one yet, but we do know that the width of the rectangle is going to be X. Okay, so this goes back to what is it that's forcing a certain value for that length if I choose a certain value for x. So again, if you want to temporarily give this another variable name, you're welcome to. It's up to you. You can decide whether you need that or not to help you figure this out. So the thing that's forcing a decision on me is the fact that I have 1 mile of fence. So if I go all the way along the bottom and then all the way up to the river, that has to total 1 mile of fencing, which means an x plus a y plus an x has to add up to 1. So y plus 2x has to add up to 1, which means the length y has to be 1 minus 2x. So our 1 mile of fence minus the x over here and the x down here. This x right here is absolutely involved in calculating the area, but it's not involved in the fencing part. The fence just runs around the outside of this rectangular part of my picture. So back to this, 1 minus 2x. Okay, so there's my area equation. And again, I'm going to simplify a little because my goal is to eventually find a maximum. So I have a 1/2 x squared, and then I'm going to distribute an x in, plus x minus 2x squared. And then I can combine some like terms. If I have a 1/2 x squared minus a 2x squared, I get a negative 1.5 x squared. So I'm going to make that negative 3/2 x squared. So my area formula is actually not that bad. The window one's pretty messy, but this one is not too complicated. I'm going to go ahead and start looking for, I want dimensions of the largest possible pen. So if I want to maximize area, this is quadratic, negative x squared means it does open down. So I'm getting this shape. I'm looking for this point, the vertex. This one is actually simple enough that I think I'm going to go ahead and factor and go about this by finding my x-intercepts first and then looking right in the middle for my vertex. So if I set this thing equal to 0, I get an x equals 0 and 1 minus 3/2 x equals 0. I'm going to go ahead and do the work for this because that's messy enough. I think it's really easy to get upside down. So I'm going to subtract 1, and then to get rid of a negative 3/2 multiplied by your variable, you should divide by negative 3/2, or in other words, multiply by the reciprocal. So we're going to multiply both sides by negative 2/3, which is going to give us positive 2/3. So in my picture, this thing goes through 0, 0, and 2/3, 0, 2/3. Okay. Which means the x-coordinate of the vertex is 1/3. If you want to get the biggest A, and this axis represents the A's, this represents the X's, you should let x be 1/3. So if x is 1/3 of a mile, you will get the largest possible area. We were looking for dimensions here, so you can describe this how you'd like. I'm going to give my x and my y. I think if I was, actually, I'm going to think about that twice. If I was describing to somebody how to build this thing, I would give them the x and I would give them the x plus y. So if this is, what did we just say, 1/3 of a mile, then this will have to be 2/3 of a mile. Again, if you define variables or label clearly for me, I'll be able to tell what you got. But thinking about trying to give this answer in a way that's really useful, I think is great. So let's go 1/3 of a mile by 2/3 of a mile. And again, if you've defined your variables, I'll be able to tell which side was the 1/3 and which side was the 2/3. So that's 2/3. So that's great. All right, thanks for watching.